Hi, my name is Ellie McKenzie, and I'm from Hernando High School. I'm submitting my project on a solar racer that I did this summer in a competition held by my local utility company. It was there to promote youth interest in solar energy. The rules require me only to use the given solar panel and electric motor, but with some calculations I made, I was able to figure out a lot of things. Now, if we plug those into this equation right here, we're able to calculate a track time of 5.62 seconds at 100% efficiency. And I was also able to calculate the terminal velocity of 50 miles per hour at the end of a 60-foot track. Whew. Good, that's behind us now. Here is my solar panel test rig. It was used to optimize the solar panel's output. And with the reflectors, I was able to intensify the sun's ray and get as much output from the solar panel as a AA battery. But without the reflectors, the power was reduced to as much as a watch battery. Also, this thing was very impractical to have hanging off my car. This is my motor test rig that pulls up a weight and from which I can determine the power output. Now let's hook it up to a solar panel and see it in action. Another test was the motor test rig, where 5-gram nickels were added inside the container to test the motor solar panel performance. After making theoretical calculations, I knew it was time to choose my body. I decided on a modified teardrop shape because it reduced drag and turbulent flow and increased laminar flow. To achieve laminar flow, a car must have a smooth body and an elongated tail. But the real challenge was creating this body evenly, smoothly, and cheaply. So, as a compromise, I decided on the wedge shape. The wedge shape was a good compromise because it was simple to build, reduced drag, and the solar panel could be fashioned to face the sun. But once tested outdoors, I realized there was a huge flaw to my wedge shape. The wedge shape was not particularly good in crosswinds because the crosswind would either knock it over or make it tug on the guidelines, slowing it down, while the teardrop had laminar flow, allowing the air to pass over smoothly. Since the wedge shape idea didn't work out too well, I decided to go back to my modified teardrop, but building it was still a problem, so I began to research some more, and I found human-powered vehicles, aka HPVs. I learned that HPVs were actually quite similar to my solar racer, and so with the information from the HPV builders, I found a material that was lightweight, easily shaped, and inexpensive: foam. Since the gravitational force is pushing the car down the incline and the wind is pushing it up, the car stops moving when the sum of the forces equals 0. The distance the car is pushed back indicates the amount of drag that particular car configuration has. In other words, a high drag body will be pushed up the hill further than a low drag body configuration, like the streamlined teardrop shaped body, as shown in the test next. This is the primitive wind tunnel I made. Now let's see what happens when we crank it up. Wow! Wind tunnel track is slanted at a 5-degree angle towards the wind source, so the car will roll down to the fan. Therefore, the driving gravitational force of the car going downhill is opposed by the wind force. The rolling chassis got pushed back the furthest by the wind tunnel because it had the most air resistance. The wedge shape was pushed back the second furthest because it had less air resistance than the rolling chassis. The modified teardrop shape had the least amount of air resistance and was not pushed back as far as the other two models. This makes it the most aerodynamic out of all three bodies. The process and calculations will be described more in detail in the PowerPoint. This is my final project, my modified teardrop solar racer.
It's 9 in the afternoon. Your eyes are the size of the moon. You're good 'cause you can, so you do. We're feeling so good, just the way that we do. When it's 9 in the afternoon. Your eyes are the size of the moon. You're good 'cause you can, so you do. We're feeling so good, just the way that we do.
Thanks for watching!